This is my Twitter for those of you. How many of you guys have Twitter here? Okay, some of them. Yeah, okay. So Twitter. How many of you guys have email? Okay, it's email. You can send me email at Viktor at Hazelcast. I just explained that we're still not extremely big, so we have everyone in the company. They have their own, like the Viktor or Fuad or Greg, CEO of Fuad is co-founder. So we have a.
How's your Viktor spelled?
It's with K. Good.
We had two Viktors this month, and both initials VG, except the difference was the K versus the C. So,
exactly.
yeah.
Yes. So, and I guess, yeah, exactly. Victor, he spelled his name with, yes, he spelled with C. So, yeah, so I'm going to talk about some of the things that we recently kind of developed and we sharing stuff. So, how many of you guys use Java 8 at all?
A little bit, yeah.
Okay, so some of you use Java 8, and Java 8 is awesome. So many people waited Java 8 for quite some time, and there is a very nice feature that we're going to talk today. So about myself. So okay, so my
Small fiction.
Yeah, went sideways. Anyways, so I work as a solutions architect with a company called Hazelcast. As a solution architect, I basically solve problems. I do things. I work with customers. I work with on the pre-sales, post-sales fashion. I do provide the support. I'm sitting in, going through the tickets from different customers. So the reason for that is that we're not selling some box software where you can explain pretty much every use case in the frequently asked questions section or stuff like that. It is very. What I like to say, Hazelcast is very explicit. It's highly customizable system for building systems. So it is not just a library or framework or software piece of software. It's many things, and I'm going to explain some of them today. So I also work as a developer advocate. So that's why I'm talking to the developers in the conferences. I work in online. In the Stack Overflow and Twitter, I'm looking at the places where people actually, complaining about the things that something doesn't work with Hazelcast, how we can make them happy so they can use Hazelcast. And I all over the internet, GitHub, Twitter. So if you have a Twitter, you can tweet me at here. If you have a Twitter, definitely follow me in Twitter. I'm a very interesting person. And today we're going to talk about, I'll start with explanation some of the use cases, and we will talk about Java 8 streams. We'll talk about a little bit of distributed data and how we in Hazelcast approach this problem, and why it is needs to be distributed, and how to process it using the Java 8 streams framework. So, and at the end, I'll try to explain about some of the internals, how it works. From perspective of the engine that called Hazelcast Jet. So just a little bit spoiler here. We're going to talk a little bit at the end. Okay, I'm going to talk about word count today. And I don't know if you know, guys, but the word count is considered as a hello world application in the big data world, meaning that it is. Pretty simple algorithm that you need to implement. There's no there's no need for figuring out algorithm with less complexity. Usually, why word count? Because word count also word count used for benchmarks, and why it used for benchmarks because it allows to see raw power of engine, regardless if it's Hadoop, if it's a Spark, if it's a Flink, or something else. So I'm going to talk about word count. Easy to grasp, to understand what it does and how it does it, and very easy to understand how to, and very easy to port to other frameworks. So yeah, we can take a Spark, and usually people know that if you need to run some distributed processing, you need to go with Spark. Start learning Scala. How many of you guys know Scala? Okay, some of the people. Okay, yeah, this is why I'm here, because Java is much nicer than Scala. You don't need to read like this Chinese, the ASCII art stuff. I'm just kidding. It's just the one library that does all these things. Is the Scala Z, but the people saying that Scala is just a better Java. Just use it as a better Java. Do not use the Scala Z. It's bad. Even Scala people think it's bringing some of the unnecessary complexity. All right. So let's talk about the word count and how it will work in general. So with the word count. The concept that I'm going to use here, we have a map that will represent the stuff that I will load from file. So I load from file line by line some of the text. In this case, I'm going to be using, I will show what I'm going to be using. The line number will represent a key in this map. And the value is going to be actual line. So after that, I need to find out how many words I have in this file. And there's an additional task for today. We're going to do how to find the X number of words. So what needs to be done for this? It's easy, right? We need to iterate over each line. We need to split it into words. And after that, we need to somehow update this running counter with new word. Like new word comes, we need to update the counter. And we're going to be counting words of two of my favorite artists, I would say. It's Disturbed as a very awesome band. How many of you guys heard about Disturbed? They play really, really heavy music. Very helps in a gym when you're in some heavy sets. And Lady Gaga. How many of you guys heard about Lady Gaga?
Oh, yeah, I've heard.
Lady Gaga is awesome, right? Because she's great. She's doing amazing jobs, and the different albums are not the same as it was previous time. She's doing many different things. It might be disco, it might be some more traditional pop and the stuff. So I love Lady Gaga as well.
And what does she have to? Oh, I see. That's the.
Yeah, we're gonna count words in the songs
Gotcha.
of these artists, and we'll see maybe there's some correlation. Maybe they have some similar words in their lyrics. So basically. If you use Java 8, just straight Java 8 without anything else, it's simple, right? So we're going through this map. We're loading stuff from the file into our map. We're going through the line by line, and as a value, we'll take a line. After that, too fast? Okay, so we're splitting the pattern. It's basically a regex that we have. In Java, splitting by pattern, just by words, and if word itself is smaller than 5, we accepting this because we will remove some garbage like smaller words like and, or, the, etc. And after that, we're using this very neat construct that we have in Java 8. How many of you guys heard about the compute method in map? All right, do you know what it does? Okay, what it does?
Sorry, but from this side, it's difficult for me to explain to you.
No, in general, what meaning of the compute method in map, in Java 8 map? It allows you to provide.
No, I know it. So English is not my native.
Me neither, so.
And in Russian, you'll translate.
Yes, you can say it in Russian, I can translate.
Really?
Да, я могу.
Cool. So the map filter and all of them to work with stream of the Java 8.
But it's not filtered. It's really just one method that you have in map interface. It's fine. It's okay. I will explain. Yeah, let me explain. So the way how compute works is allow you to provide a function that allow you to compute a value for this map. So in this case, we will have a map named counts that will have a key, which will represent particular word. So we will have instead of having map where we have a key as a line number and the value as a line. We will have different map. We will transform into another map which will contain word as a key and value as a number of occurrences of this particular word. So in this case, I will have a key by word. For example, it's going to be hello. And in case of occurrence of entry with the same key, this function will be invoked. So basically what it does is just function that takes two arguments, left and right, or like the first word, and we will produce a result that will contain, if its value is null, we're either providing 1 as a value, or if there is value already occurred, we will just simply add. So in this case, it will look like we have a hello, hello, my dear friend. So we have a 2 times hello. In this case, hello will be occurred once. We'll put 1 as a value. The second time will hello occur.
Is W up there in the dark somewhere?
Okay. This is why I ask. Like, what do you guys know about? If you guys know about Java 8. So in Java 8, compilers became more smart. And can throw away some of the type information, and compiler can figure this out. So the basically idea of compute method, it will accept lambda with that, it looks like this. So it will return some value, and it will get some 2 parameters. Type is really, it will be inferred from the type of value of this particular map during the compile time. So W basically, here you're providing a lambda that will define the merge function for this compute method. So if you will take a look on this, so give me a moment, I will pull up the Java doc real quick. So we have a map interface, not JavaScript, we have a Java interface in Java, and there's a method called compute. So it accepts by function, and by function takes 2 arguments and return 1 result value. So for particular key, you will take this by function. By function itself looks like this. So it will take, where's my method apply? Method apply takes 2 parameters and will return some value. It's basically some of the generalized function of function that takes 2 arguments, and this is why here you're providing this something like this, right? So this is 2 input parameters. This is your result. So for example, in this case, if you have key with the same key that already present in the map, the method compute will be invoked, and this new value will be passed here. So this way how it looks like, the value of this map will contain the previous and in new value concatenated in one in this map. And from perspective of how it looks like if you forgot this syntax, it looks like this. So we'll take a old value, we apply this function to get new value, and basically at the end we will do the map.put. So it's just Java 8 simplifies the way how we're dealing with the collections, particularly. In this case, it's more like functional approach. You basically passing the function into this method compute. So let me, before we go, I'll show you, where's my Tweebot? I'll show you like some of the things that we do in Twitter. And one of the things, okay, I don't have internet, it's fine. I should have it somewhere in my downloads. So basically something like this. You can be confused with lambdas if you're still using Java 7. Just play smart, play simple, play smart.
It's easy to understand if you have some practice with the arrow function from the ECMAScript, for example, or from the lambda function from .NET.
Similar, yeah, but in this case it's just not fat arrow, just thin arrow. Yeah, you can also have a brackets here. It's just one-liner because it allows you. It should.
You can explain any function. If you need to more than one row, then you need to cover it.
Yeah.
By the curve breaks.
Yep. Yeah. So idea that you should remember this, and you should get a good understanding, because we're going to use this pattern in a different way syntactically, and after that we will bring this pattern. It's actually a very powerful pattern, because the previous step, like the previous iteration or previous value, it really doesn't. So there's no connection between this step and the previous step, because at this point it's given that this map already contains something. And it's up to this function to calculate actual value. Okay.
What again does clean word do?
Which one?
What's clean word?
Okay, so clean word, it's just a function. It just will remove some of the nonsense from here. Maybe it removes some of the whatever. I will show you the code. I have a code. It's just a clean representation word. Maybe to strip some of the spaces, strip some of the commas, etc.
Take a word, turn it into lowercase. If it's already there, add one to the count.
Yeah. So for example, if you have a hello in I don't know, lowercase. So clean word will get it in the, or like there's a camel case. H capital, E small, L capital. We will just want to have it in the one nice clean representation. And after that we'll use the lowercase. I'll show you the code. Now, okay, so this is basically already Java 8 syntax, this one, right? So it's already Java 8. Now we go into the fun part where we can define a, how do you call it? Okay, good stuff. A pipeline of operations. So basically Java 8 streams, it is not a data structure. It's just an abstraction that represents a sequence of operation that we applied to your collection of elements. So it's not, like I said, it's not data structure. It's some sort of abstraction. Okay. You have a source. You need to get some sort of result. So streams provides these sets of steps that your data will travel to get the final result. And this stuff, this stream, it never modifies a source. So streams are always producing either another stream or it produces another result. So, okay, it's going to be good explanation.
One of my favorite pieces.
Yeah, Five Guys, exactly. I actually, I was kind of not very good in researching audience. Maybe if I just simply forgot. I just did the same slides for like audience where I have like Indian guys. Have another one very fun picture. So basically, let me put this from perspective of explaining how the burger works. You know this, like this is pipeline. So they starting with the preparing some of the meats here. No, I just strip this out because to make it more concise, in particular in this case. This guy, like the burger party, goes from grill and goes through the some of the pipeline of operations. They have a bun, have a tomato, salad, and stuff like that. So the same stuff. Streams basically provides to you. So there is some intermediate operations which will create another stream. There is some terminal operation that will actually start executing. So the cool thing about this Theorem thing is that it's a lazy, meaning that you can do multiple operations, but only certain operation will actually start executing this. So this is why there is a room for providing some improvements. So for example, some of the operations can be reordered in order to perform faster, or maybe run some in parallel and multiple threads, etc. But the only terminal operation will start actual execution. But also there is a operation called the blocking operation that will produce that will not start execution of threads of the stream, but also it will sort of block, for example, sorted. It needs to rearrange the previous steps in order to continue. So it will be sort of blocked, but will not execute the stream at this point. Now,
quick question, Viktor.
Yes.
So I think you said in the previous slide that the stream is not altered? with
It's
somebody's
not
application?
altering your initial source. So
Right.
if you have some collection, stream is not changing it.
Right.
It will always producing something more. Either it's going to be value. In this case, your method reduce always return some value, or it's going to be collect that will produce alternative collection. Can be another list set or whatever the collector you have.
So for sorted, you'll get another
Yeah,
like
no.
substream or another
Stream, yes.
Right, okay.
It's going to be sorted stream basically.
Right. So you have your original plus then the next other.
Yeah,
Yeah.
yeah. So if you guys familiar with Spark, anyone knows like what's a Spark RDD? Spark RDD has a similar concept. It has how they call it transformations, and they have it transformations in something else. So basically, this is analog of like intermediate operation transformations, and there's also some operation that will execute. It's terminal operations in Java 8. It's just a refresher because you probably already know this. Okay, so how it fits into the Five Guys stuff. So you cannot call burger something that doesn't have a bun on the top, right? So in Europe they call it open sandwich. Open sandwich. So you start with something in the very beginning and you're putting layers on the top. And only after that you're putting the bun on the top, you executed burger.
They call
So-
it Atkins in America.
Say it again?
They call it Atkins in America.
Oh, it's open.
It's a diet fad. It's a diet fad where you don't eat any starches
Okay.
or sugars.
No carbs, right?
All
No
right.
carbs. So it's
I know
take
that
one out, it's Atkins.
in and out they call it like protein style. So where you don't have a bun, but you have a salad. It's still burger.
All this talk about burger joints is making me hungry.
Well, we just ate dinner.
Nah, it's still making me hungry. I'm looking at that and I'm like, whoa,
You have your to-go box.
Like, yeah.
Yeah.
That's right.
All right. So let's see some code, right?
Great picture.
Okay, so basically what we're gonna do here, we will operate with the same code over and over again, and we will try to transform it and put it into different different places. Can you see it? It's okay if I will. It's better, or the black one is okay.
I think either way is good for me.
All right.
Black
so-
is better.
Cool. All right. So basically, you already seen this code at the very beginning. Everything starts with this guy, right? So we have. Let me show you a little quick how this method looks like. So the field map with data, it is basically does what it says. It's just reading file and read line by line, create some of the local map, and this populate the map we're providing as a source. And I will explain why I'm using this kind of approach rather than returning this map later. So in this case, it's not maybe extremely how it's called, like functional, because this map will be modified, but you will get the idea after. Now, so it is very straightforward. We're going here, we populated this map, we're running this, we've seen this code already. So let's see how it looks from perspective of Java Stream API. Oops, too much. Yep, this guy. So, the first of all, we need to get a stream. So, how many of you knows like which interface brought us a stream method into Java collections? Like, okay, I will say collection. Yeah. So yeah, if we will see exactly, yeah. All right, so if we'll take a look, collection. In Java 8, we'll get this method called stream. I need to buy this guy because it waits for too many times. So basically, yeah, all right. So we get this method called stream that will allows us to do these operations. And the interface stream itself contains different number of methods. As you can see here, some of them are, for example, let's do FlatMap. So FlatMap actually returns a stream as a result. So in this case, you know this, it is a intermediate operation. Or some methods like, let's do a count. Count returns values, meaning that this is terminal operation. Or method collect, that will also return some value based on the input parameters. Or method sorted. Okay, too long. Yeah, definitely need to buy. Great app, by the way. It's allows me to see like Java docs. So to your question, Mike, the sorted also returns stream, but in this case, it's going to be see, it's called stateful intermediate operation.
Oh.
And you can read about this in Java Stream doc. So it's there. Now, so the map, it doesn't extend a collection, right? So map itself, it's not a collection, so that's why we need to get something from the map. In this case, we get an entry set, which is going to be a collection of elements, key value. So we get an entry set, and now we can operate in the stream because set is a collection, so we can do all this like pipeline. So we're getting the stream from this collection. So FlatMap. So FlatMap is a very interesting function. So what it does, it produces a stream that will contain stream. Basically, FlatMap allows you to create stream of streams, but because it's gonna be too inconvenient to operate in this one, so it will just provide one stream with many elements. So as you can see, so for every entry that will come here as a parameter of this FlatMap, I will remind you that FlatMap accepts the function. Function itself is an interface that has one method. Where is it? Apply. So it takes one parameter and returns one parameter, just a function. So we go into this one parameter. In this case, the type of this parameter will be, who can help me here? What's going to be type of this M? Exactly. So we can also have this like this, right? In this case, it's also fine, but it's going to be a redundant type of the thing, right? So you need to provide the type here and stuff like that. So compiler will figure this out from the type of the overall flow. Now, as a result, FlatMap needs to return a stream. So this is why we're creating a stream of words in this case. So we split let me show you pattern. It's all regular expression that will just separate these lines by words. Now, and we're creating the split method will return you an array of words. Array itself is not a stream, so we need to produce a stream from this array. So in this case, it looks like this. We're creating this stream from array. In Java 8, you can create the stream from any structure. You can also do something like this. Something like this, or you can do stream of even something like this, right? So it is going to be stream of integers, or it can be stream of anything else. So, and if you do something like this here, stream of, you will see that this stream will contain stream of strings that came from this guy. Another thing, so the next element of this, the pipeline, will receive a stream of strings. So in this case, this stuff can be written like, where is it? With lambda. Yeah. So this will take element from the stream from the previous call, and will just produce another stream that will contain element in lowercase. In Java 8, we have this like a shorthand syntax for that compiler will figure out what to do with this one. That's called method reference. So with method reference, the argument of this function will be pasted here into as an argument of this one of this call. Again, I'll show you this picture. Remember this, right? It's already complicated if you didn't use it in the past, only you spend some time to understand this. Another thing, the clean word, it just basically replaces everything is not a word or a letter from here into the some empty place. That's it. It's just some methods. Basically, it shows how we can apply different transformation of their stream. So the FlatMap produces us from a stream of key value pair from the map, produces a stream of words. Now we passing the stream of words through this from this pipeline of the operation like lowercase, clean word, and after there's a filter. So filter will take a predicate, which is another functional interface that we have in Java 8 that will simply has a method test, I guess. Yeah, method test that will return a Boolean. So predicate is a function that allows you to decide yes or no, true or false. So in this case, it will filter stream, it will provide filtered stream, which contains only words that were previously lowercase, cleaned up, and now it will only contain, the next collect call will only contain words bigger than 5. Okay? Now, the next part is also pretty cool. So now we have this like transformation stuff, but we need to get the result at the end, right? At the end, we need to apply some sort of terminal operation. In this case, we need to produce another result. We need to produce another data structure. So in this case, we want to produce another map that will contain, so remember, as a result of the previous step on this stream, we have a stream of words already cleaned up, lowercase, and more than 5 symbols. Now, as a key here, we will take the parameter. So the key here, the type of this key would be inferred as a string because it's the input value from the previous step. As a value here, we will put just 1. Very similar to the things that we did, where is the symbol? Very similar that we did here. So it is our key and it is our value 1. And basically here, here as the merge function, they call it like merge function. If I'll go to map, you'll see here there's a mapper for the key that will create key, the mapper for value, and the merge function. And the merge function also a binary operator that will take, where is it? Where is the method? Basically by function, which we already learned from the previous step when we talk about the compute method. By function will take the 2 elements and produce 1 result. So the merge function here will be also responsible for doing things like if it's already value 1, we will just increase it. And here we can also use very nice method reference syntax, which if we'll see here, it's also by function. You already know this because it takes 2 arguments and produces 1 result. It is by function. So compiler smart enough to take any type of function and figure this out. In the compile time, it will generate so basically some stuff that will represent the object or method call or whatever. So in this case, some method, it's also by function because it takes 2 arguments and returns 1 result. Okay? Now, And after that, we need to play this out and see what kind of stuff we have here. So let me run this, and we will see what kind of output we have here. Plus, I have around some of the nanotime that allow me to get some of the timings. So the first one, I'm just playing the printing out some of the milliseconds and stuff, but I'm not printing the result. So my result, let me do something like this. I'll do something like this, and I'll do yeah. So you will see what kind of counts collection we have here. So this is how this map looks like. Pretty much all words have just one occurrence because they kind of like, I don't know, like what's the chewed? Interesting. So there's only one word, the chewed in whole War and Peace book. So it's kind of interesting. Plumper, whatever it means. Anyways, so now it produces us collection, not collection, it produces a map, which contains key as a value, as actual word, and value what contains the count, right? And now I'm also interested in learning how I can get a top 20, for example, in this particular case. So how can I get top 20? Also, I'm applying another pipeline. I'm applying another stream operation. So in this case, I'm do filter. So in this case, I'm using some of the stop words. So excludes contains words like that basically doesn't make any sense. They exist in the the like word like with. It doesn't make any sense. Now I want to sort after that I did this filter. I want to sort it. So I will have sort by value, basically. So I want to find the word that has more counts on the top and all the way to the bottom. So in this case, I'm also using some of the compiler magic, I would say, right? So in this case, map entry has a built-in comparator that will have something like compare by value. See? So it's also okay. Let me show you real quick. So the sorted will take a comparator as a parameter here, and because I don't want to write my own comparator, that there's out of the box comparator. So in this case, comparing by value inside the map.entry interface basically does. We have a first the one value and another value, which is comparing to which one is bigger.
What's the double arrow symbol on that same line?
Basically it's just the type of generic, because this guy returns a comparator. Yeah, it's just the IntelliJ. Yeah, it's IntelliJ that sort of provides the diamond operator shorthand.
Oh, that's okay. That's okay.
I don't have the latest version of IntelliJ, but the latest version of Word. What's the HTML one? WebStorm.
Yeah.
And it actually does some replacements of operators.
So you can focus on the actual thing, so you will not see some of the clutter.
It looked like an if and only if. It looked like a bi-directional.
Plus, it's kind of So from perspective of like a typography. In your ID, you probably see some, something like this.
Greater than, and it replaces it, right?
Right, exactly.
And
so in this case,
greater than or equal, actually with the way you would write it out with the greater than. And
this one. So for example, if I'm writing something like this, it's called ligatures, I guess.
Okay.
They have it in fonts. You see, enable font ligatures, and my font actually does support this. If I'll do like the fat arrow type of thing, or I can do like something like this, it will create sort of more I don't know, like ICGNJ things. I kind of used to this kind of syntax.
That's the way of putting it.
Yeah. Now, so at this point, we have a sorted stream. We will take just a top 20 and also producing another map. So another method actually can, because in this local map, in the map that we have in the Java, we can also provide a the method that will, or not the method, we can provide the container where this result will be written. So this is why after all this operation, I'm also providing linked hash map because I need to preserve order, right? So I'm going through this operation. It's a mapper function for a key, same way as this, pretty much, for value. So really, I don't care what kind of value I will take. I'll just take one of the values. And also I will produce the sorted and ordered the data structure. So in the very end, I will see where's my accounts, and obviously Pierre, Prince, Andrew is I can say from this, even I read the War and Peace in school back in the day. I still can say that Andrew was a prince, and he was the main character of this book, right? So, based on occurrences of the particular world, you can figure out, okay, so this is kind of book about, it's Russian book, okay.
And obviously, if he wasn't talking about himself, he was talking about the princess.
Yeah,
about
exactly. Yes. So, yeah, this is this kind of stuff. Okay, now. Okay, I need to do like one. Okay, we talk about. Okay, so I'll talk about the distributed. So, but in general, I can say, hey, Viktor, what the hell? So we have this like very cool the UNIX command called. Oops. Huh? We know this, right? What we do this. Word line character byte count. Why the heck we need this nonsense where we can easily use the word count to all do this stuff? And I'll say you're right. So from perspective of application, certain tools needs to be used for a certain type of task. So if you see everything, if you have a hammer, you see everything as a nail, basically. And if I see something, I have a slide for this. If I see something that is suitable for Java, I see it as a subject for Hazelcast, for example. But maybe it is not. Maybe it is not. So in this case, you need to think about some of the tasks that you're trying to automate with writing your application. Maybe it's not distributed task at all, right? But why go to distributed in this case? So, and again, as you can see, so I have almost 2 seconds from startup of the JVM to produce. So let me go this. We will use the where is it? Word count utility to. Okay, looks like my. Come on, my ship stopped working. Okay, if I go here. I'll do see resources. Okay, have my War and Peace. I'll do VC or -L will give me a number of lines. So 65k lines. If I'll do so it says what's the size of this one? It's in the bytes. Who can tell me how I can do it in megabytes? So it's in 3 megabytes basically, but it's relatively big, but it's still like in 2 seconds. But you know, maybe it's not best application for a computer with like 8 cores. Maybe. Yeah, so it is maybe not good application for this kind of test, but you have a massive. You're trying to analyze the words in the Gutenberg library or Google Books or whatever. So in this case, we need to go distributed. So let me talk about this a little bit, about how to go to distributed world. So are we guys good, or we already, I'm start losing you at some point? Huh? We good?
I'm wondering what applications people use Hazelcast for.
Yes, I will talk about this. Yep. So, so how we can do this in distributed, right? So Java 8 provides you way how you can parallelize this operation. So there is also parallel stream that will use either the thread pool that you supply, or it will just use the fork join thread pool that available by default. You can use it, but how we can run it across not multiple threads but multiple JVMs. All right. So first of all, let's figure out what kind of problems that we have at this point. So first of all, if we want to talk about distributed world, and if we want to talk about some distributed application, we definitely need to move some object around. Meaning that we need to take the object, we need to somehow serialize it, and send it over the network to another JVM. Because a distributed means that we need to have more processes. Now, all these functions that came with the Java util stream, they're not serializable. So you see this functional interface, it doesn't have serializable. So you cannot send this over the wire, this command. So you need to come up with some version. So what kind of rationale behind this? So the standard Stream API provides you parallel execution within a single process. And the design of Java streams assumes data locality. So the operations like sorting, it's kind of trivial when they run within one JVM. But if it's run within the cluster, it's a whole new different story. Now, I already mentioned non-serializable lambdas, non-serializable functional interfaces, returning non-serializable results. So for example, if you call collect, it will provide you just a map, which is not serializable as well. So in case of distributed streams, it needs to provide a serializable version. But you can say, okay, Viktor, where is it? Too fast. Probably my battery is dying here. You can say, okay, so what's the problem with these guys, right? So the entry said, oh, okay, too fast. For some reasons, I kind of missed very important slides. Just give me 1 second. I will find those. Oh no, I didn't just ahead of time. But let me start with this one, right? Why we need to distribute it? Why you need Hazelcast and stuff like that. And after that, we will return to the. Yeah, this is Hazelcast actually. So this is kind of stuff that I saw at the Hazelcast booth at the Java one when I talked about how I joined Hazelcast. Okay, I saw this layer cluster and the people just pulling the wires from it, and the data still there. I said, hey, I want to work here. So this is kind of like this is kind of stuff that I saw at the booth and just like, hey, I want to join them, and plus they have money. So the why anyone wants to use a cluster technology and the other things. Something is maybe my. Let me try another USB. Something wrong with my clicker. My clicker that I use for already 3 years. Okay. So it's not simply easy to take put all data in one machine. Sometimes data is too massive to fit in one machine. Things like the word count, like accounting some books, I can run a laptop. It's fine. It's not that gigantic. It is nothing to compare to the that maybe some of the data that collected from devices that connected to, I don't know, the collecting information from the patients, collecting information from all these sensors that, temperature and stuff like that. The data is simply too big, so you need to go to some distributed way. Or data is too important. It's also another case where you cannot store it in one computer because you need to have redundancy. You need to have some other copies of this data, and that's why people come up with some ideas how we can store it. Like, for example, Oracle has this product, Oracle Coherence, that has the distributed caches, also support the distributed streams. We'll talk about this. It's also a commercial tool. And this looks like this with Oracle Coherence. Pretty much everything that you just saw in my Java code can be done here, right? With only difference is that it actually invokes remote collector to produce like serializable results. So the source here is not local Java map. It's a data structure named cache. They have this concept of caches. From the cache you can get a stream, kind of like stream from the cache, right? But the rest of the stuff looks exactly as you saw. But this code will be executed in the grid, in the cluster. Same with Infinispan. Infinispan, it's open source in memory grid, also has distributed version of caches, also provides Stream API. But hey, is it that easy to use? It's a simple API. Is it allow you to be embeddable? Let's use Hazelcast, right? So why use something else? So the Hazelcast itself, like the product that we have like for years, it was released in 2008 under Apache V2 license. It's also recently rebranded because we released another one. It's called Hazelcast Jet. We'll talk about this a little bit later. So now we call it a memory grid. So it's a memory data grid. In memory data grid, simple thing that you need to remember today. In memory data grid is the system that provides you distributed storage and distributed computing capabilities. So you have the network of computers that might run this Hazelcast process. They form cluster, and you can use it for distributed storage, and you can use it for distributed computing. So when you want to use it, if you're writing a Java applications, because Hazelcast AMDG designed to be distributed version of Java collections. Pretty much same stuff what you did with your hash map can be done with Hazelcast map. But in this case, this map runs across multiple processes, right? And all this cool stuff that explains Apache V2 license, distributed version of Java collections, JCache, which is a standard Java specification for caches, some messaging, distributed computation, and stuff like that. Awesome open source projects. We have an incredible number. So it's not only Hazelcast employees. So we have contributors to Hazelcast all over the world. It's cool stuff. Okay, let me talk about some of the code. I have code here because running. Yeah, I love this slide. We're also using this concept storing the backups in memory, which means that we use another node to store some data that you have in one node. So it looks like this. So from perspective of developer, you can do. Your data looks like a whole. When you look into this distributed map, you're operating this as simple as you operate on the hash map. But internally, data is sharded across multiple entries. Multiple nodes. Some of the data has a primary, stores in the primary partition, which means that the data will be served from here. But also, we have redundancy in another node, so we can store the backup of this data. So in case of this guy would go down, data will be stored from the backup, and we already have this data over here. I'll show you in. We will returning to this guy. So with Hazelcast, let me do some coding here. Right. Okay. Computer. Something is not right. Maybe it's IntelliJ idea is going crazy. Okay, now, and thankfully we have things like, well, restart always helps. Just restart. So this is a price that you pay for running the early access builds. Something always doesn't work. So the first thing, let me actually, to demonstrate you some of the ideas, I need to start one tiny process which will sort of run the web app. It's called Management Center. Boom. We can target. Okay. Management Center. Okay. Looks like I didn't build it, so in this case we go into to downloads Hazelcast 3.8. Go in here and do Man Center. Java manager. Management Center. Okay. So what it does, it will help me to visualize some of the concept that I just explained. So the Management Center is the Spring-based application that allows me to monitor some of the aspects of the Hazelcast process. Okay, and incorrect password. Damn it. Okay. Okay, so there's a universal solution for everything. Like if it doesn't work, you can always restart. We do so Management Center. All right. Sometimes it's just a simple too many passwords to remember, and I don't remember what kind of password I used for which one. So username, admin. Boom. Boom. Yeah, this is my mail. You can write me to Hazelcast. Admin. Okay. Cool. Management Center. Can you see it well? All right. So from perspective of the clustering technology and things that some of the things that you can do very easy with things like Hazelcast. Just give me git revert. Okay, cool. Now you. Okay. So let me start with something like simple Java class. We'll do test member. So the way how the programming with Hazelcast looks like, it's incredibly I would say simple. If you do static void main, public static, yep. Oops, static void main, one, yep. So the first thing that you need to do is create a Hazelcast instance. So Hazelcast instance, it's a process. In this case, it will run within JVM. It exposes certain ports to listen because it's a still network system. And so from perspective of operating this or like dealing with something, so I can do Hazelcast, get map. I will call it war and yeah, because I will use this map to populate this the War and Peace book. So in this case, my line will be integer, int, and the value is going to be string. So the way how it looks like, remember my field word util field map with data method that will take the file name. That file name I have here in my resources folder, which is War and Peace. I'll do so I can copy name, copy, and I will put this map that I have here as a parameter. And exceptions. Okay, so this is how we're dealing with exceptions in Java, right? Someone will deal with them after us, so we just our method need to throw it. So the cool stuff, as you remember, this guy doesn't know anything about any like a Hazelcast and stuff and anything else. So it just simply takes map, and because a Hazelcast map here just extends the concurrent map, which extends map, I can use it here. And I just, simple API will just simply, with this couple lines of code, will start the process and will populate it with data. So I will do this. So it will compile it, obviously, and it will start one of the nodes of the Hazelcast. Boom, 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 boom. Now, if I'll switch to Management Center here, just do refresh, the Management Center was able to figure out, okay, so some guy here joined this, and there's my War and Peace map. As you remember, number of lines that I run is WC minus L, which is give me number of lines. And if I'll go here and say, what do you have on line 42? Integer. To browse, and it will give me some string here. Maybe it's empty string. So we will try next one. Another empty string. Okay, let's do something else. Another magic. Yep, we have something here. So basically, for each line on the file, we have some entry in the map. Now, okay. In this situation, I'm kind of like a modeling way where I running in the one node. But what if I want to sort of increase storage, right, for this guy? So in this case, I'll go here. I'll just do another one. Let's call it another member. So why not? I'll do public static void main. And do another Hazelcast instance. Simple as that. So that's it. Nothing more. So we'll just run it. And in a couple seconds, it will join another node. In the Management Center, we will see another guy. So if I'll go to the home screen, now I have another member. See? So another member joined, and I can do this kind of stuff like all day. I can just run it once again. So it starts another process. It's another process starts another Hazelcast member. It joins the cluster. And the cool part here is that data now is not stored in what? Okay, cool stuff. So in open source version, it doesn't allow me to run in more than open source version of Management Center. Obviously, I can run the cluster with many nodes as I want. So let me kill it so I can demonstrate some of the cool features here. Yeah. Start complaining. Just get back to work. Now, 2 nodes, running with 2 nodes, data here is not replicated, is not copied around, but data, you see, in total number is still 65K, but data now is sharded across 2 nodes. So we can use some extra space to store some backups. So meaning that, as you can see here, number of entries here equals number of backups here. Meaning that if I will kill, remember the first node was responsible for loading data, but what happened if I will kill this first node? I'll go here and just kill it, right? Okay, die, it's gone. Will I lose the data? No, the data is still there. I don't have a backups though, right? Because there's no other node that will store these backups. But it still doesn't really matter. And we will start another node here. And again, I remind you that this is just a simple map that we pass here, populated with data, easy to use. Okay. Cool. It will reshuffle some data. Okay, data reshuffled. Again, we have a number of entries here, number of backups here, all good. Data redundant and data is safe. Now, so let me kill this. So from perspective of usage. By the way, was it clear that I just showed, or does it require some of the explanation?
So it looked like it was almost something synonymous to Spring Boot, right?
Nothing to do. I didn't go there just yet.
Okay.
Spring Boot is the next part. So,
okay. But you're able to, a couple lines of code, you're able to start a web server.
So in this case, the management center is nothing to do with Hazelcast cluster at all. So its management center allows me to easy to demonstrate a couple things. But for example, I just killed the management center. I don't need management center. I will just close this tab. So what I can do here, for example, is if I don't have management center, I can do something the standard. So something standard, for example, like okay, I don't have internet. Okay, the things that I can do here is do something like this. Properties, say Hazelcast JMX enabled and value true. So in this case, I will use a JMX and the standard tool for seeing some statistics through JMX. So what I will do here, I'll start JVisual or JVisual VM.
Victor, is everything Hazelcast hosted by Hazelcast?
What do you mean?
Can I buy Hazelcast software and run it on my own servers?
Oh yeah, of course. It's you don't need to buy anything. It's just it's open source piece. If you're interested in some like a commercial things, we do have those, but you don't need to buy anything. It's like I said, it's 100% open source thing.
What?
Just maybe
Hazelcast host?
No, we don't provide any hosting solution because I guess it's not that we're not in this business to do like the hosted solution. We're just doing the software so people can deploy it whenever they want. They can deploy it in the cloud. They can deploy it in on premises. So it really doesn't matter where you can deploy it. It's just So from perspective of deployment, where is it?
Are there preferred providers like Amazon S3 or Azure?
There's no like preferred provider. You can use whatever you want. Hazelcast explicitly, so we don't really tell you where you want to run it. Hazelcast runs everywhere where you can run Java. So except Google, how it's called, App Engine, because it's their Java, because it doesn't allow you to do like a socket communication. We need socket communication to build to establish cluster connection. So from the way how it looks like, you see, I don't know if you see here, I just enabled JMX and I can see this cluster process running here. So let me connect to this one. Okay, so I can do plugins. I guess I need to use, do have available? I guess I need internet.
We can connect you.
There is a Wi-Fi?
Yeah. Should I mention that? I forgot, I'm sorry.
Okay.
All you have to do is type in a 29-letter code.
Okay,
Say
so
the wall. Yeah,
29 doesn't work. So what's the password? It's a long one? Okay, then never mind.
Dictate it. Wait, I have it.
Okay, so let me see.
Are you ready?
Oh, you got it? Okay.
No, I mean, like, it's fine. It's okay. It's totally okay. If I need it, I would just connect from my phone. It's fine. Why the heck is this thing doesn't work? Let me try it again. JVM. JVM. Yes. Okay. So we're switching to Russian, so you guys, you can relax here.
Not so fast to change the language.
I can translate after, it's okay.
So, насколько я понял, там получается, вы просто создаете множество потоков, или это разные хосты с разных машин?
Okay, so the question was like how it's done, if it's like multi-threads or it's multiple the processes. It's actually a different process. Это другой процесс. So,
Я все понимаю, просто не могу
okay,
говорить.
all right. I don't know, like my computer behaving like we're weird today. Just my Java stuff is not starting as usually starts. So when you start the Hazelcast instance, it's basically another thread in the concept in a context of this like particular application. But in general, you can do like executable jar where we start this as a separate process. So basically, if you can start two Hazelcast instances within the same process, it's possible to do, but you will not get the redundancy in case of the particular JVM will go down. So you will kill two instances. That it's not very practical to have two instances. Yep, it's something something with Java today. All right. Never mind. So basically, what I wanted you to show is that you can see some of the statistics. Can I do it from IntelliJ?
Okay, what is different between the parallel process for streaming which provided by the Java 8?
Okay, so Java 8 doesn't provide you with any streaming. It's an API that, from my opinion, poorly named as a Stream API, because from perspective of actual streaming, it doesn't stream anything. It's incredibly poorly chosen name, because we already have a stream. You have an input stream. Mm-hmm. This looks like more like a stream, right? Yes, I understand your question. So you were talking about something like, if we can do something like this, instead of stream, we can do parallel stream, right? So in this case, like I said, the parallel stream will be run in this case in.
It will work in only one machine, but it will use more than one thread.
Exactly, correct. So in this case, underneath it will provide you the parallel version of the iterator called parallel splitterator that allows you to run different pieces of your computation in different threads. And at the end, collect method will collect all the stuff from all threads, which is totally fine. This is a kind of way how you can run multi-threaded version. But what if you have so much data that you cannot run this even in parallel? You need to run it in the cluster, as I already mentioned. You have so big data, or data is very important for you. Mm-hmm. So you need to do this something differently. So the way how you can do this with distributed version, same stuff that you saw in with standard Java. Only difference is that now it produces iStream So now you learn a little bit about Hazelcast. So I do have this the member that will populate here the Lady Gaga, populate here Disturbed songs, and after that I will run this computation in the cluster. and the result will be saved in the cluster. So let me start this guy. That will, again, here as you can see, I'm starting to Jet instance, but it's same as a Hazelcast instance. I'll talk about this a little bit later. So we'll start this, and we will see it in Management Center real quick. I'll do localhost 8080 Man Center. Okay, I killed Management Center, obviously. Let me start it, and I'll show you what do we have here. I started one JVM process, but I can start multiple Hazelcast instances here. So in this case, I'm running cluster on one JVM. It's not practical to do this, but it is something that you can. So for example, for testing here, for demo or for testing, I'm showing you how you can do this kind of things.
No, I understand that. Just open some different thread from the different machine and just synchronize from the socket, and when some source started to reading, you just share the base source and working on the data on the parallel machine, and sometimes it's extra data, so you send not for one machine, you send two machines to have a backup, and it's like the it's like the coach of the MongoDB, like this, the parallel, and then if you need to, you can again to collect it by some rule. Correct. But here's the thing that you cannot do on the things like a Mongo or stuff like that. Mongo is basically a storage. It is database, distributed version of database. It's just a small metaphor.
Yeah.
To explain some. So when you start to aggregate or filter any data, you do it in parallel. So you not serialize the process. You just make provide the same logic on the more than one machine, and just to work with the same data sometimes if it's backup, and to get result. So it's just если говорить с этой точки зрения, то получается вы считываете все и просто раскидываете на всех на источники, а потом это обрабатываете. Но, как бы сказать, данные так останутся в облаке, если
это не облако.
Ну, как бы в кластере. Если их надо будет собирать обратно, то это...
Okay, I will talk. Okay, so the question about collection, like what's it gonna be, how you can collect this data. Okay. So I have a slide for this. Yeah. So what's the problem with doing this? Basically, what you're asking is that when you run this, the IMAP is distributed version. So when you do values, you're just bringing all stuff that you have in the cluster in one VM. So what's gonna happen? That's it. Yeah. So like I said, remember the previous slide. The data is too big to have it in one machine. Your client is not capable of handling this stuff.
You distribute this data to more than one source who will work with this data.
So Hazelcast has two main options: is distributed storage, map-like key value storage. There's also like querying capabilities, but it's not the point. And the second one is running computing next to your data. We're not pulling the data somewhere to process this. We run the process next to the data. So in this case, you don't need to have a client that you need to pull somewhere this data to do the processing. So this is exactly what happens over here. So you would do the values, you bring in all these values or entry set to the client, and after that you do local processing. Why you need to do this when you can do the cluster process? So what I'm doing here, so this stuff. So from perspective of usage of this API, it looks exactly the same as you do local processing, but underneath this stream code, am I with stream? Yep, sorry. This code, there's no parallel stream. There's no parallel stream here. this stream will be sent to the cluster to perform operation next to your data. Remember when I showed the slide that the Java util streams assumes data locality. So in this case, we also can provide you data locality, but in a cluster sense. So this operation, this call, when I do things like collect, stuff like that, it will be executed in the cluster. So let me show you. So when I will do the thing like, okay, it's a wrong example because I'm getting wrong map. The map source is not there. Okay, so there's no map source. Let me do things like, what's the Lady Gaga underscore source, for example. Lady Gaga underscore source. Gaga source, sorry. Gaga source. So I will use this map that's already there in cluster. That someone already put this for me. I just need to do like a fast computation, and I put the results into the Gaga counts, meaning that when I will done with this computation, data will be already in the cluster. So I don't need to upload this data back. So this framework assumes data locality in the cluster. Okay, so let me show you. So the way how it works, connected to the cluster, writes data to this, and if I will open the cluster, I see here Gaga counts. And if I'll do browse this map, I can say, okay, now it's a string. I can say, okay, love, it's for do this browse. Because she's saying like a million reasons about love and stuff. So in this case, it has a map that already has our result without leaving the cluster. Just, in most cases, the computational part is significantly less than the data that you have in the cluster. So, and as you notice, this happens like even though it's local, you can say it's local. Hey, exception. This map. It's not Windows here. Nope, it's not that way. No. So Windows is a different type. The question was about, is it like when you're dealing with batches or Windows? It's not the Windows from perspective of the processing. It's still more like how it's done at MapReduce. So your data already mapped. The data is distributed. Now you just need to send a computation based on the key. So the way how it works, this piece of computation will be sent to each node, and it will work with the subsets of the data on each node. And after that, it will write in the same nodes. So you don't need to do this like a reduce in terms of like a bringing results to the client, because here, as you can see here, this is collect runs on IMAP. It's collect runs on it's a IMAP collector comes from distributed collectors. So you don't need to bring the result back to the client, right? It's stored inside the cluster. So it's a different logic. Similar thing that, for example, Oracle Coherence provides with remote collectors. They cannot store inside the cluster after the result. They just can, read the result back. Hazelcast can do this as well. So you can do just to map, and you can use a traditional, you see this collectors to IMAP. You can also like write it back. You can also read it from the cluster and put it in your local client. But this is not the purpose. The purpose is that when you have a grid, you're not dealing with grid as you're dealing with database. It's not request response. So you don't need to pull something to compute locally if you can run it inside the cluster. Sorry, maybe it's a part I was not articulate very clearly, but the things that you have with the grid is not only the way how we can store distributedly in distributed fashion the things like collections, but also you have a computational part. Computational part like executor service. Okay.
So is there like a web API to do analytics so the client can read what's on
Well, there's no. It is the web API. There is a REST, but technically yes, but it's not about analytics.
But people don't use it that way.
So you can use this as one of the sources that you run some analytics. For example, if you're running analytics with Spark, you're using different sources. You can run the Spark with files. You can run the Spark with some database, Cassandra, and after that, Spark will do this kind of like a join where you can get like aggregated result, and you can store it somewhere, like in the files, in the Parquet format, or in the Cassandra. Hazelcast would be one of the sources like this. It can be used for analytics. And it's fast to use for analytical type of use cases. Is it designed to be used for analytics? Maybe not, because there's some limited amount of like aggregated functions that available, like out of the box, just a simple like a count or group by available. So you need to write this logic. So in this case, analytic tools more designed for the people to to drag and drop, create the nice report and done. Here it's more like a developer needs to come up with this. What exactly with logic of this analytics. So this is why the main point here, I guess, is to explain how it can be used from the people who already use the Java 8 API. Right. So you already know this, and you've done this multiple times with your parallel stream, for example. Now it brings it to the cluster, brings it to more distributed world. Okay. Any other questions? Okay. So now let's go to some of the insights. How it's done. Let me actually just one more second. So when I show this in the projector, for example, the PowerPoint starts incredibly. Sorry. When I work late night, I use this app that actually dims some of the display lights and makes it more suitable for night illumination. I just don't understand why it's too dark. So what I wanted to show here before I jumped into this thing. What I was talking about?
Hazelcast.
No. I mean, I know this. Streams.
Jet.
Anyways, I will get to that. I will remember.
Warned you we had a bunch of comedians here.
Huh?
I should have warned you we have a bunch of comedians.
Oh, it's fine. It's this makes us like how many? Like I'm one of you guys. You see, I'm wearing red pants, so
That's
this is my presentational pants. This is
Jet. And then there's Ruben and the Jets.
Anyways, what I wanted to say, I forgot. You guys.
what's his name? Paul McCartney?
That's right.
Anyways.
That's right.
So let's talk about how it's done. So first of all, the Hazelcast came with just one jar. You can just take this jar. Use slideshow. Yeah. So you can take this jar, you can embed this application, or you can start multiple processes and form the cluster, and you can use the Hazelcast client to connect to this cluster. So basically, in general, with Hazelcast, you're always using one jar, Hazelcast all, which contains pretty much everything. It's 8 megabytes. It doesn't have any external dependencies, so we don't have any other libraries. No, I'm lying. There's one library. It's Eclipse JSON that we actually shade inside the Hazelcast but the rest of the stuff is it's written by us. So there was a time when we decided, okay, so let's bring another jar that will allow us to do a little bit more than the current grid has. So the current grid has multiple beautiful things that I already explained. Some of the distributed data collections, and some of the distributed primitives from Java Util concurrent, for example. We do have cluster-wide atomic. So if you need to have like a cluster-wide counter, we're already providing this. So you don't need to write your own like database-based synchronization, atomic, whatever. So it's already there. Or we also have distributed version of Java executor service. So you can say, okay, have a runnable, just make it serializable and send it to the cluster and execute it in the cluster. And not necessarily needs to do something with data. You can do some things that not related to data at all. We even can define some of the members of the cluster that will not store any data. It's called light members. Light members can be used, for example, you're writing some of the distributed job processing system that will invokes some of the commands on the UNIX server. You don't need to store any data. You just simply need to send the runnable there. This runnable will run some of the command in your system, and it will send the result. Now, why we need to have another the distributed processing system? This distributed executor is a pretty powerful concept. However, it's still low level. We need to deal with many things like how we're gonna behave in terms of failures. So Hazelcast provides the durable version of this executor service. If you run some of the job, you kill some node, the durable executor service will reroute and automatically start this job in another place. However, how are you gonna deal with the situation when this job already done something? How you will, deal with like a fault tolerance and other things? Different the checkpoints, if you need to incrementally update something, and so far so on. And it becomes doable, but it becomes not extremely productive for the people to use this kind of low-level concept. So we came up with this idea of running this distributed computation platform on top of the in-memory grid. So the Hazelcast IMDG will do heavy lifting. It will provide all this network because it's already there. So Hazelcast IMDG runs in every cloud possible. So this guy Jet can reuse it. So we don't need to like reinvent the wheel. We just need to reinvent the model of execution. So this is what pretty much Jet innovates into the Hazelcast IMDG. So it's a distributed data processing framework. It's a generic. It's not necessarily needs to be related to some of the pieces of the Hazelcast. Again, it's based on a DAG model that is more high level, that allow you to describe the way how the data flows and how you can use different. I will talk about DAG in the next slide. But how the data will flow through the system, built on top of the Hazelcast MDG. Okay, it means that, as I already said, heavy liftings already provided for Hazelcast. And to sort of like signify this kind of Hazelcast Jet built on top of Hazelcast MDG, I have my Hazelcast Jet on top of my Hazelcast MDG issue. So basically, you understand this. It's it does heavy lifting. This look pretty and makes it everything easy.
So, are there underneath all this? Are there red pants?
No, I guess it's my personal brand element comparing to the. We have like everything orange. You see, even my the stand, the bag also orange. So everything is orange, not red. So the way how it's DAG is a directed acyclic graph. So directed because it goes to one direction. There is no directed, and acyclic means that there is no loops here. So you cannot return where you started. There's always the beginning and the end. So on the very beginning, there is some source of the data. This source can be, I don't remember if I have a slide here, but this source can be anything starting from distributed map, JDBC, file, or it can be some streaming source. So for example, Kafka or JMS, where these messages will arrive and you don't know when they will start arriving. So, and each vertex defines a step of this computation. So for example, it will go here and it will do like a map function. So in this case, it will enrich the data. Here it will be like a filtering vertex. It will filter data. And it goes through here and at the end it will end up in Hazelcast map. So when we run this, it will the instance of this DAG will be serialized and sent to all members. So it will be executed on all members of the cluster. And I'm going to go in very much details here, but underneath it's implemented with very interesting model called cooperative multitasking, which basically implementation of the green threads. These different elements of this DAG will be executed in tasklets. That tasklet is very small task. It's a very small unit of work, and one physical thread, actual thread, can run thousands of tasklets. So with this approach, we can actually bound some of the execution to the processor. We can bound particular thread to particular processor. So in this case, there will be no context switching, and there's no like shared state from perspective of they don't need to share anything. It's just the functions that will be executed, and this function will have a input and output. That's it. So there's no need to have a state or shared state across the thread. So in this case, this model allows us to run this massively in parallel, not only through the and use smaller number of threads. From perspective of the benchmarks, we took some of the standard benchmarks that are available in big data world, basically word count, run this with 1 million words and some other things. And as you can see here, the MapReduce, it's basically Hadoop. It's Apache Spark, Apache Flink, Hazelcast Jet, and Hazelcast Jet. We run this in different versions. Current version 3.03 something 3, I guess, or 2. And we go into the 0.4. It's pretty stable. It's not even version 1. Anyways, and also we run this comparing to the standard like Java Stream. And at some point, the Jet can outperform. Okay, so here's a kind of quiz, like why. And the thing is the way how everything in Java done. They simply design some of the things that end up in the standard library in the sense that they will cover, I guess, 95% of use cases. This 5%, this is like how the 5% of use cases came out into play. So basically, Java Stream is not designed to be executed with unbound stream. So it needs to know what would be number of elements that will be executed in this Java stream. In this case, it can sort of optimize and create, for example, in the case of like a parallel stream, create like particular number of threads. In this particular case, it will use like same code as is without providing any hints. In this case, it kind of we sort of like provided the dimensions for this stream. So in this case, after that, Java stream code was able to optimize it, and internally it runs. Obviously, it's faster than DAG, even though DAG is quite close. But it's kind of interesting that, and the guys from the JDK, they obviously not gonna fix this like 5% of use cases because it's already have enough other problems to solve than like solving all the problems in the world. So that's why like people still coming up with their own implementations of even like 4 join pool. Like Scala has its own, not even they don't use JDK and stuff like that. So pretty powerful, pretty performant. So in terms of future, so what we're doing this, we run this as like a stream processing, a real stream processing framework, where you have an unbounded data stream that comes in the system. So we need to deal with some of the streaming features. So this is actually your window. So it is possible, but not with the Java Util Stream API. Java Util Stream API is inherently batch process. It assumes that all your data, yes, it assumes that all your data is there. Your data is there.
I know. I just to try to guess your approach to decide to build your how to say the applications or tools. So I just to try to understand. It was one of the guests to understand your approach, because your solution is not so how to say unique. It's one of the approach like the another tools which provide.
Wrong.
Why?
It's unique. So yeah, okay. So
it's unique every time for one guy to develop it.
No, I understand. So okay. So how it can be? I'm not gonna say here.
Sorry. One question.
Yeah.
Как долго еще? Насколько у вас долго перечислить?
I have no idea. Like how long we're gonna stay here? Like I said, like if until where's he left? He left. He said like we need to stay here. We need to stay until 4 a.m. But he left. I guess like maybe like 10 minutes and stuff like that. Right?
Sound good.
Yeah.
Cows come home.
You guys good?
Yeah.
Yeah.
So no, it is actually unique. So when you're dealing with the solutions like Spark, for example, right? Have a similar concept. Spark is also DAG-oriented system. Allows you to write Java and Scala apps. Wow. But Spark has very heavy, I would say, lineage. So Spark comes with whole family in law. So you need to deal with the things like cluster management. You need to deal with these things like if you're running on Yarn or you're running on Mesos, or where your code will be executed, because your code will be executed in the cluster, your code will be executed partially on this driver, or it's a Flink. That same also comes with like a family in law when 150 megabytes of jar dependencies.
It's just another condition to use another.
Exactly. Yes.
If you can get the same result by the different approach, so it means that all products the same.
No, that's not true. It's not true. I can make the person productive with Hazelcast in 10 minutes because it doesn't have any stuff any fluff around. You can start very clean.
Okay, I buy it.
No, I'm not selling you. I'm just explaining you. You ask me how it's unique.
I buy your idea.
So okay, no, don't need to buy it. Don't need to buy it. It's open source. Just go there. Download and play around. You will understand this. So Hazelcast inherently, from the very beginning, has one rule in mind. It's the developer productivity. In these days, we have very short attention span when we need to learn something. So because there's like a Facebook, there's Twitter, there's LinkedIn, now LinkedIn here also, things like that. So when you start doing with like Spark, you're doing this Flink stuff, any type of big data tool, your time is constantly growing because you always struggle with something. Even we experienced developers in this field, we have very hard time to set up Flink cluster to run this benchmark because there's something that happens, and I consider myself as a very experienced developer. So my colleagues, they much smarter than me. They struggled with building this kind of solution. With the Hazelcast Jet and the Hazelcast in general, we simplifying this. Just like I said, 2 jars and very nice clean API that allows you to be productive in 10 minutes. It's embeddable. I'll show you some Spring Boot example, how it can be back to the Spring Boot example. It can be run in Docker. It can run any cloud because it's a simple, doesn't bring any family-in-law dependencies, doesn't depend on environment. This is unique. You will not get this. And probably even in your organization today, you have some of the system that you bought and running that internally use Hazelcast. So systems like the Payara, they use Hazelcast for clustering. WSO2, like Enterprise Identity Manager Server, the Artifactory HA, and many others, like the MuleSoft. They use Hazelcast internally, and you don't know this. So the thing is that it's so simple, but it's not primitive. So it is very easy to start with, and don't buy it. Just go yourself and try. Just download this and see. Just go through the tutorial, spend 10 minutes, and I'm not saying that I'm giving you like your money back, because I'm not. It's free, right?
So how do you guys survive? Is it service?
Yeah, because we're awesome. yeah. So the couple things we do: providing services, we're providing consultancy services, we're providing the customer support for open source, we're providing some of the enterprise level features. So some of the plugins that build on top of the enterprise thing. So it's a typical commercial open source company. So in this case, things around multi-data center replication. Typical person who builds like the application, they may don't need this. But if you're like a big bank and you care about redundancy across data centers, you care about disaster recovery and all this stuff, why not? So we do have it, and just get it from the people, get support, because cover your policy is always type of first priority in the bank environment. I know this. So yeah, in this case, the open source was there. Like we were in open source. We grown from the open source, and we do open source first. We go in there. Like there's a chat where you can chat with developers. Like literally the same people who writing the code. GitHub is always open with stuff that we do with new releases. So yeah. So let me show you. Okay, so instead of conclusion, I'm not gonna do from slides. I'll show you how it's easy to run with Spring Boot. Yeah. Okay. So let me start my member once again. So I will populate with some data, and what I will show you right now, it's going to be a Spring Boot application that will. This is how I start my Spring Boot application. My configuration. So the way how it looks from perspective of Hazelcast and configuration it from Spring Boot, I instantiated this the Hazelcast instance bin. Jet instance bin will be instantiated, and there's one file that I have in my class path will allow me to build a cluster. So for demo purposes, I always use the TCP, because I don't know like if I'm running on some unreliable environments. So, but by default, multicast is on, and which means that once you start this and start another node, they will look up, they will discover each other really quickly. Now, so I start this. Where is it? Yeah, I started Jet instance, runs with 2 nodes. I have one of the sources that contains source of disturbed with double B, and contains Gaga. Now, my web application contains one controller. So this controller has two URLs. One URL will provide the name of the artist, in this case, and it will execute this like a word count scenario. And another one, it will get top X words from this song. So if I will run this Spring Boot application, and as far as I can, as far as you will notice here, where is it? If I will show you external libraries, all this crap came from Spring Boot. Hazelcast part here is just one jar. Where is it? One jar of the Hazelcast Jet and one jar of Hazelcast all. That's it. Rest of the stuff is not mine. So okay, I run this. Or I can do even simpler. Let's go like let's go old school. Let's go from console, right? So I'll do HTTP. HTTP, it's a pretty nice curl-like utility. So I'll go to 1990, and it goes with the what was the artist name here? Not found. Okay, so let me check the URL where I'm doing this. Slash word counts slash distort. Okay.
Oh.
So what it does, it just returns a number of size of the map that contains this word count. You see here, it counts. If I will go here and I try to find something interesting here, like reasons, maybe I don't know. No reason. Okay, 2. Okay, criminal. 6, because there's a song about criminal. What else? What's the okay, suffering. Good. Now, so we can go something like let's do top 20. And it returns the sorted version of this. Okay, so world, another inside thing, destruction. See, destruction, and I will query this map for destruction, and I should get the same number, 12. Cool. All right. So let's use. Let's change something. Let's do. What is my artist look like here? It's Gaga. Okay, we'll go with Gaga. So it's 376 unique words here, and let's do top 10. Million reasons. Okay. Angel, illusion, the perfect illusion, Pinot Noir. Okay. No, not Pinot Noir. Pinot Grigio. Pinot Grigio girls. Okay. So now the way how it looks like, it's pretty simple. All this wiring done by Spring Boot. The Hazelcast part here is just this word service. So word service has 2 methods. One method that runs the word count, that will take we're passing the map that we're interested in, and top words will just run the same code that I showed you over and over again. So again, the selling point is that this API, like the collections API, I assume that many Java developers know Java. There's no question here. Many Java developers know Java collections, and now as Java developers, you also know Java util streams, the way how you can operate over Java collection in Java 8. With familiar concept, we will just take you to the distributed world if you need to run it in the parallel across multiple machines. And I guess my favorite slide here for today night. Hopefully we don't have many people who sleep today. So in this link, I will post this video after.
People sleep.
Just come on. I don't know, like the PowerPoint is like behaves strangely when I run it on the...
That's because it's a Microsoft product running on a real computer.
As a matter of fact, I actually enjoy the use of PowerPoint for... the Office is great on Mac. I like Office very much. You can tweet me here. The Hazelcast, all different things, news about Hazelcast. This is like some of the hashtag, in Twitter they use it like hashtags to, you need to search something or you need to mention something.
Okay.
Say it again?
I tweeted the picture of you.
Oh yeah. So and this is Java SIG for New Jersey.
Sorry, yeah.
ACGNJ.
But what is that a picture of? I mean, obviously people sleeping, but where was it taken?
In the classroom.
I don't know. Just go. It's in Google. I just went to Google and get some like a stock photo that explains
the story behind it. Somebody was
That was required.
Yeah, so this is basically pretty much it. I don't know like how helpful it was that. At least I tried very hard to not sound like a salesman, but at least provide you reasons why this kind of technology exists and why we're doing the things what we do. I guess the main thing is that right now it's becoming more and more important with distributed system is that the Moore's law is not applicable anymore.
Yeah.
So we already exceeded capacity of one machine. We cannot just increase the cores or increase clock of the processor. We go in distributed anyways. Distributed systems is the theme for the last like 4 or 5 years. And the systems that allow you do complex things easier or like do complex things in a way that it's possible and it's not that complex. I think it's a future. So this is why we're keeping it simple, we're keeping it lean, and we're not providing like a bloatware where we can put whatever possible framework that we can. But it's totally up to developers if they're interested to use it or not. So and without, I'm pretty much 20 seconds to 10. So.
How does the design fit with the large databases projects that are out there, commercial and
You can free the code back.
So
like IBM?
So thing is,
I'm thinking of LevelDB for one, which is sort of a write-only database.
Okay.
Level DB.
so how it fits with database. So Hazelcast is a middleware. So it is not. It can be used as operational store, but also it can delegate some persistency to any underlying database. So there is the pattern called read-through, write-through cache, which allows to cache to manage who's writing or who and how it's reading from database. Typical cache scenario where you have a cache aside. So you go into a cache, check if you have value cached. If it's not there, you go into database, you're getting from database, you put it in the cache, returning result. So next time you go into the cache, it's there, you're returning. So the cache, a read-through cache or write-through cache is that you always just, basically talking to cache. And the cache keeps the data coherent between, sorry that Hazelcast talking about coherency of the data, but again, naming, it's another big problem that we have in the computer science. The naming and cache invalidation, obviously. Two hardest problems. So basically, they keep the data coherent between cache or consistent between cache and the underlying database. It can be taken by this read-through, write-through cache solution. So Hazelcast, fits there very well. We in memory, we don't provide any storage except memory and network out of the box. Like there is some enterprise feature that allow you to have a local kind of like, when you close the lid of your laptop, you have this hibernation mode where the content of the memory will be dropped to the file. We sort of have this similar concept, but in distributed fashion. You have a cluster, you're shutting down your cluster, every node will be placed in the local file. And after that, if you need to restart it, so you have a massive cluster, you have a terabytes of data, it would be, maybe days to reheat this cache again from other system or from other database. Now, we can restart this fairly quickly, depends on the underlying storage speed, but the current benchmark shows that on SSD drives, we can restore a half a terabyte of data in one node, less than 5 minutes.
Victor, just a quick point on the tasklets. I was reminded of the hamburger. So a tasklet would be putting ketchup on top of the hamburger, and that it operates independently. Each one of those tasklets has its own bottle of ketchup.
You can say that. But in this case, instead of one huge hamburger, you're basically creating like some small sliders, and these sliders. So your hamburger already kind of like distributed across the cluster, like in sliders fashion. So it will create another sliders, and the tasklets will work on this like individual piece of these slider rather than on particular step of this operation, like ketchup or mustard or the mayo or something like that, right? So it is more.
And the hamburger is never reconstituted. It's
Yeah.
always virtual.
Exactly. It's kind of like, it's very difficult to come up to write metaphor for explaining this kind of thing, because, for example, I have this in the past. I have this like picture that explains people replication versus the partitioning in with example of have a one dolly ship and this cloned dolly ship, it's replication, and after that I have a sliced piece of lamb, but you cannot create like a whole thing, but you got the idea, right?
Yeah.
So it's like the same thing with the hamburgers. It's always virtual.
Let's thank Viktor for
Thank you.
Thank you, guys.